Hello, my name is Guillermo Cuellar Malacara. I'm a student in the Master of Science at Universidad Autónoma de Nuevo León, and I will present a poster entitled Comparison of Two Synthesis Methods to Prepare a nitrogen bromide oxybismuth with incorporation of magnetite to degrade endocrine disruptor compounds by heterogeneous photophantom process. First, we have in the introduction that the advance of industrial modernity and high consumption has increased environmental pollution. Emerging pollutants, particularly endocrine disruptor compounds (EDC), like bisphenol A (BPA) and 17 alpha ethinyl estradiol (EE2), are chemical resistant to conventional treatments that represent a risk to human health because they cause adverse effects on the endocrine system and alter the reproductive function of organisms. Due to this, advanced oxidation processes have been proposed to address this problem. In particular, bromide oxybismuth exhibits high photocatalytic activity under visible light. On the other hand, a catalyst is modified with iron can react with um, hydrogen peroxide to improve the degradation of contaminants. And in this study, nitrogen bromide oxybismuth with an incorporation of magnetite was prepared by coprecipitation, a cheap and easy synthesis method, and by isothermal microwave assisted method, a fast and efficient via. The activity of materials on the degradation of BPI and EE2 was tested by heterogeneous photophantom process. Here in the methodology, we describe both methods. First, we have the thermal microwave assisted method that in a small reactor we add in one beaker CTAB solution, urea and ethylene glycol, and in another beaker we have the bismuth precursor and ethylene glycol. The first beaker is added to the second, and then we add the magnetite. Then it is put in ultrasound for 10 minutes, and then it's passed to the microwave to 70 100 to 7 to 60 100 to 60 degrees for 10 minutes, and then it's washed with ethanol and water. Then it's dry at 80 Celsius degrees for 12 hours. Then it is characterized. And then for the composition synthesis, in one beaker we have the bismuth precursor with water, magnetite, and acetic acid and urea. Then it is put in ultrasound for 30 minutes. And in another beaker we have the potassium bromide and sodium acetate. Then it's added to the first beaker. Both solutions are put in serum for 2 hours. Then it is washed with ethanol and water, dry at the same condition, and characterized. The characterization is made by X-ray diffraction analysis, scan electron microscopy, UV-Vis spectroscopy with diffuse reflectance, nitrogen physisorption isotherms with PET analysis, electron paramagnetic resonance spectroscopy (EPR). For the degradation test, we have the small reactor that is put in solar simulator, and then we have here the conditions that was used. The BPA and EE2 mixture with a concentration of 5 milligrams per liter for each, it is added. Then the pH is adjusted to 3, the concentration of 60 millimolar for the hydrogen peroxide, and the volume of the reactor, the catalysis load, and the intensity of the lamp. And then after we take samples for 15 minutes for 2 hours, and then is read in the HPLC with the following condition that here we present. And the control test we made for photolysis, only radiation, absorption, only catalyst, heterogeneous phantom without radiation, and heterogeneous photocatalysis without hydrogen peroxide. Then well, like we have in these images from the same analysis, spherical flower-like particles assembled with nanoplates were observed in the catalysis obtained by microwave-assisted method, like we have here in the letter A and letter B images. And for the letter C, we have with those obtained by coprecipitation showed open flower-like with roughness nanosheets. Well, this was similar to those observed in other works. However, like we can see, the nitrogen bismuth iron that is made in microwave also presented a small spherical particle that are weighted to magnetite on the surface. Like we can see in this, like these small particles. In figure 2, we have the diffractograms of the materials synthesized obtained by microwave assisted method for letter A, computation via for letter C, with detailed view for the height peaks for letter B and letter D. The displacement of 2 theta degree in XRD patterns was another differences between synthesis methods. The shift to the left and right is depicted as contraction and expansion of the lattice respectively, as we can see in figure B. This also affects the crystallite size, which is bigger with the co-precipitation method, as we can see here in table 1, comparing both methods. Then by microwave synthesis, we can see the difference here with the crystalline size that is bigger it's bigger for the microwave synthesis than the co-precipitation method. And then in figure 3, we have the APR spectra of materials prepared by different methods. It was evident that the incorporation of nitrogen and magnetite in the synthesis method affected the generation of superoxide and hydroxyl radicals. Like we can see in the blue line, we have the bigger intensity and for the microwave assisted method than for the co-precipitation method. And finally, the complete degradation of VPA and E2 was achieved only with heterogeneous photophantom in 150 and 80 minutes. As we can see, the blue line with the small triangles have the bigger degradation in comparing to the processes in the individual. Then in conclusion, we have the synthesis method of bromide oxybismuth affects the morphology, crystalline size, and specific surface area. When nitrogen bromide oxybismuth with magnetite is irradiated, the addition of hydrogen peroxide allows efficient degradation of BPA and AE2 compared with other processes like heterogeneous photocatalysis, due to the microfield system method promotes the due to the synergistic effect between heterogeneous photocatalysis and Fenton reaction. However, the microfield system method promotes the vacancies of oxygen generation on the material and favors the formation of oxygen species such as superoxide radical, enhancing the activity of the catalyst compared with the precipitation method. This study contributes significantly to the degradation of emerging contaminants in wastewater, highlighting the low cost and low time of synthesis of the catalyst, which contributes to the development of sustainable and efficient materials. Here we have the references, and finally we have the acknowledgements. First, this work was supported by the Facultad de Ciencias Químicas of the Universidad Autónoma de Nuevo León and the PAICIT UANL project, and especially Morales Flores, thanks to CONACYT for the fellowship. And this is all, and thank you.